Welcome everyone to the next video of this Microprocessor 885 lecture series. In today's video, we will learn about stack and subroutines. This is a completely theory-based lecture, and this usually comes as a long question of 10 marks in exams. So if you write all of the examples and points in detail with pros and cons, then you might score good numbers. So yeah, that's it. All the best for this video. So let's start with stack. Now what is stack? It's a collection of memory locations, operates in last in first out manner. Basically it's a data structure where the data is stored in last in first out manner. So by now I think you already know about stacks, and the only two operations that can be performed on stack is push and pop, right? Either we can push some data or we can pop some data. Push is inserting, pop is deleting. And obviously you should know that SP or the stack pointer, it's a 16-bit register. It's a special purpose register inside the MUP which holds the address of the top of the stack. I think you have already watched the architecture video and all of you know by now that what is SP. And obviously why top is essential for stacks, because if we know the address of the top of the stack, that's it. We can operate on any data if we just know the address, because the data will get stored at the top, the data will get out from the top only, right? Okay, so now it comes to the uses of stack, in which fields stacks are used. So there are 4 points basically. I will discuss them one by one. First is obviously to store data. Why data structures are used? To store data. So I think you can see properly. As you can see, I have used a register called DE. Now I can store data in the register by just writing MVI D comma something or LXI D comma 2015, right? But what is the problem if I store data in registers and not in stacks? When we are using registers, there are only handful of registers. There are only a few, only 6 general purpose registers that a programmer can use. So we can't use registers to store data always. We need something else. We need memory. Inside the MUP there are 64 KB memory. So this is why stacks are used to store data. So how this goes on? Suppose I have taken 2015 data in DE register. Then I have written push operation. Okay. So push will, this is higher address, this is lower address, this is your memory. So when we write push D, means the data in D and E register will get stored respectively. So D is higher address. First the data from D register will get stored at higher address, then the data at E register will get stored at lower address. This is how we can store data in stack. Now if we want to get out the data, then just simply perform pop D. Then first the data E will get out and will get stored here. Second, data D will get out and stored here. Okay. If you don't understand this point properly, let me just give you an example in computer. We have suppose 8 GB of RAM and 1 TB hard disk, the secondary memory. Whenever we are operating any operations in computer, on that particular time, that program will get will come to the RAM. This is why RAM is limited. It's only a size of 8 GB. Any program, suppose if you are playing a big game, probably it has a storage of 4 GB. So 4 GB RAM will loaded on 4 GB game will, it's a program. That program will get loaded in RAM. Okay, so when the program is going on, then only it will get stored at RAM. But it is permanently stored at the secondary memory. RAM is limited. You can't store everything on RAM. Whenever we are working on something, only then that particular operation gets stored. Same goes with MUP. If you want to store some data permanently, use the memory. When we are operating on that data, use registers. I think you're clear now. So to store data, we use stack. Second use is to store return address. I think you know what is call instruction. I've already discussed it. If you didn't say it, please watch the previous videos. What happens in call instruction? When we use functions, then we need to call that function. Using call instruction, what happens? Suppose this is a program. This was coming as addresses. When we write call subroutine, in microprocessor, functions are called as subroutines, right? So call subroutine, then subroutine, the piece of code which is written at some other memory address. This will go to that memory address, execute the program, and then return the value. Then the value should come to the address at this point. This is the return address where the value should come. But we know that PC holds the address of the programs need to execute next. It always holds the address of the present working memory location. So when we, after calling the subroutine, when the PC is working on this instruction, PC should hold the instruction of at this location at some point. This will lose the return address. This is why we need to store the return address at somewhere. At this point, stacks are used. When we use call subroutine, the return address gets stored at stack pointer. Push. The location 1002, or basically RA, at two locations, obviously it's a 16-bit memory address. So the return address gets stored at SP. At two different memory locations, the return address is stored in stack. Now when we will return the value, first the return address from the stack will get popped. After popping, now PC holds the address 1002, and this will comes to this return address. This is why in call instruction, return address is stored in stack. Okay, so now a question comes that why only stacks are used for storing return address? Because, okay, see this example. Whenever, probably, okay, let's take an example of loop. When we use a loop, the outer loop, inner loop, first you will get out from the inner loop and then the outer loop. Same goes with functions. Probably this was a function f1. So the address of first function will get stored first. Then the address of function 2 will get stored at second. Address of function 3 will get stored at address 3. Now when we are getting out of the function, when the function gets executed and we are returning the value, first we are returning the value from f3. Then first I need the address of function 3. Now stacks use first in, last in, first out method. So I need the return address of f3. When I write pop, I will get the return address of function 3. So f3 is executed now. Then I need return address of f2. Again pop, you will get this address. Again pop, you will get the return address of function 1. So for this LIFO manner, to store return address, stacks are used. Next use is to read or write flags. Now you know that flag register is a special purpose register. We can't directly access the value stored in flag register. For that we need to perform a special instruction, that is PSW, program status hold. I've already discussed this instruction also in my instruction videos, please watch them. So how can we access flag registers? For that we need to use stacks. Now PSW is a combination of accumulator and flag register. Okay, so maybe suppose there is an operation where we need to okay, so I have already taken this examples. So thought that in A register I don't care whatever the value is, because I'm not dealing with A register right now. I just need the value from flag register. I told that I got an instruction that get the value of flag register in register B. Now you think that can't be possible because I can't access flag register. How could that be possible? This can. What you have to do, AF, in F probably there is a value 0, 1 and this is XY. I don't care whatever the value is in. Push PSW means the value of AF will be pushed in stack. Okay, so this is your higher address, this will get stored at there. This is your lower address, this will get stored at, I'm really sorry. A will get stored at 2003, F will get stored at 2002. Okay, now I want the data stored in flag register in B. Okay, so okay, if in the please ignore this one. I told you that please get this value of F in B register. So first let me get out this data. Do pop B. When you are doing pop B means the data stored at AF, first F will come out, it will get stored at C register, and the data of A will get stored at B register because HLL method. Now I have the data of flag register in C. And I have told to get the data in B, so just do move B comma C, value of C will get stored at B. That's not a big deal, but what is the point to mention here is I can get my data of a flag register into my desirable register. Same thing can happen if I was instructed to store value 25 in flag register. So what is your question? Store 25H in flag register. So for that, first I need to get this value in stack. Okay, so let's store this value at register MBI C, 25. Okay, so this is BC, garbage value 25H. Push B means in stack pointer 25 will get stored at lower address and garbage value stored in B will get stored here. Now this is my top of stack. Now I want my data 25 in register F. So AF, F should get the data 25 and B will get stored at A. So for that I just have to do pop PSW, right? Then B will get stored at A, C will get stored at F. So this is how using PSW instruction I can either push or pop data from flag register using stack. Now the next use, which is to pass parameters into subroutines, I will discuss this point later on this video, because first I will give you a brief introduction to subroutines and how we pass parameters using other fields in programming, and then we'll come back to this point. Okay, so let's go to subroutines. What is a subroutine? Subroutine is nothing but a function. Whatever you call function in C programming, in MUP 8085 it is called as subroutine. So basically it's a piece of code, right, which will minimize your work. This will minimize your memory. Did you understand what is function? Suppose I want to perform factorial of a number. So you will just write a function for that program, and probably in your programming you need your factorial at 10 different places. So just call that function from those memory locations, and your program will get performed. So subroutine is just nothing but function. Now remember this line, that the first line of subroutine is the key. Just look at the first line and you will obviously understand that what this subroutine is tells you to do. Okay. By now we are learning that how you can pass parameters into subroutines. But first, what is parameters and what is return value? So parameter is a value passed by the main program to a subroutine, and after the subroutine gets executed we get a value which is the return value. Okay. Just in case, I've already give you an example of factorial, right? So if we are using a function called fact, in bracket we write n, right? What is this n? N is the number of which we want the result of the factorial. So this is called a parameter. In this video we will learn that how we can pass these parameters. First one is by using registers. Registers that works on immediate addressing mode. Suppose in this example I've taken MBI C, 10, means data 10H will get stored at C. Now call subroutine, go to sub, add C. Add C, it's the first line of the subroutine. Please look at very carefully at this. A plus C gets stored at A. Return comes to the return address, halt. What is the use of this field? Here 10 is your parameter. You are sending your parameter using the register C. Means you are already blocking a register C just to send a data, right? Using this register mode we can easily send our parameters, but only there are a few registers are there. We have to perform some serious operations on MUP. Then we need our registers. But if we continue to do this using register mode, then all our registers will be used only for sending data, and we can't perform anything else on them, right? I mean, now see, if you want to just do something, if you don't want to add C, you want to add D, then MBI D comma data and add D, that register will also get blocked. So this is why when we are using registers, as there are only few registers, so better you shouldn't use this type of method to send parameters. Okay. The next method is, I want to send my data but using memory. Okay, we can pass parameters using memory. How? Suppose MBI A, 45H means in register A we have 45. Now ST2000, store accumulator at location 2000. So in location 2000 45 gets stored. Now call subroutine, go to subroutine. It says LA 2000 means whatever data is in location 2000 gets stored. You should store it at A, and it is already it is 45. I mean, I've just used the same address. Okay, you can use whatever you want. So now A will have 45. Then sorry, something else, I didn't use anything else. Then return comes to return address, halt. what is happening in this scenario? In this, we are not blocking any register. I can use any register that I want because we are using memory here, and memory is 64 kilobyte memory exists in MUP. So not any register will be blocked, right? But what is the disadvantage of this using memory method? Now, as you can see, I have used location 2000 in this program. I have chosen this randomly. Let's just think that in maybe obviously there will be huge programs, right? At some point my location 2000 is already blocked. But in this subroutine I am using location 2000 only. What will happen then? My location is already blocked. I can't operate again on I can't operate this operation there now. So this is the disadvantage of this method, that it is a rigid method. Now you have to write, if you want to change this address, you have to write this here again, there again, right? But as memory is of 64 KB size, it solves the first method, the problem of the first method. Okay, so in what happens in using memory, we can pass the parameter using a memory location. But as the memory location of in that scenario, as that memory location is blocked, I can't operate any other operations on that particular memory location. And in some cases I may not know that the memory location is free or not, it is available or not to perform some operation. So in that case I can face some serious issues. This is why this is a problem of using memory method. Next is memory pointer. This one is my favorite. What is memory pointer? M. It stores the data pointed by HL pair, pointed by the location of HL pair. Means in HL pair there is some data, suppose 2000. At location 2000, whatever data is in that location, suppose 99, M holds that 99. We can pass our data through M also. How? Let's see. LXI H, 4000H. Obviously when you are talking about memory pointer, I need my HL pair. MBI N, 40, call subroutine. Then go to that function which says move A, M, return comes. Okay, what happens in this subroutine? I have moved my data from M to A. I need this data in M, which I have given using these codes. So what is the advantage of this method? I have to only initialize HL pair once, and then I can perform anything that I want to do. I've just initialized HL pair with 4000. Now my memory location 4000 is occupied, and I've stored data 40 at M. And I've go to my subroutine. I've just moved the data from M to A. If you don't want 40, then just change it. Suppose just do INR A, INR M, and your M will become 41. You want data from another memory location? Just do INX H. Now your H will be get 4001, and your M will hold the data from 4001. So the advantage is initialize once and you can use it at many times. At the same point, this is a disadvantage too. When we are using memory pointer, HL register is blocked because HL has to store the initial address. After this, obviously you can do LXI, INXH and DCXH, whatever you want to. You can access to many locations using this method. But HL pair will be blocked by then. Okay. So what is the disadvantage? That the programmer has the freedom to work on any memory location. I can initialize H with anything, and the consequences is it will block my HL pair. Okay. And the last method to pass parameters is using stacks. This is a gate level question, by the way. You have to solve it. The question that will come is, what will be the value of A after this execution? Okay, please don't look at this. Look at this in program and try to do this by yourself. If you can't, then obviously I will discuss, but pause the video for 1 minute, try it yourself, then you can run again. Okay, so let me discuss. What is my question? What will be the value of A? Right? Let's execute. MBI A, 10. A has 10. ADI 20. Add immediately with 20. A will become 30. LXI H, 2000 H. Initialize HL pair with data 2000. Okay. INR A is 31. Next, call subroutine. Suppose at this point my memory address is 10,000. So what is the return address? 10,001. Right? Remember this one. Call subroutine. Okay, go. Here what will get performed? Push the return address, right? So in my stack pointer, the data that is stored is 1001, this return address at my stack pointer. Which data is stored? 1001, the return address. Comes to the subroutine. What does it say? Pop H. What is pop H? Pop the data from stack stored at HL pair. Now you understand what is happening? HL 1001. So HL is now initialized with 1001 memory address. PCHL. What is PCHL does? PC gets the value of HL. So now what is PC? 1001. 1001, what is this? Return address. When your PC becomes 1001, means after this line, MUP goes straight back to this return address. This line will not even get executed. So what is the value that is stored at your A now? The last value was 31. Then obviously the halt program ends. So what is your program? So what is the value that is stored at A register, which is 31? If a layman does this program, what he or she will decide that okay, PCHL, whatever happens, MBI A, 55 means data 55 will get stored at A and then return halt program ends. The data that was stored at A was 55. No, my friend, the data is 31. Okay. What did you learn from this program? Wait. Never ever done pop operation first in subroutine. Why? Because when we are calling a subroutine, a step that has been done by the microprocessor already is it will push the return address at the stack pointer. You didn't even know that how this happens. But after calling subroutine, your stack pointer is already initialized with return address. Okay, so if you know what happens when a student does this program for the first time, even when I have done this first time, I see pop H. I thought that okay, I need to get the data from stack in HL, but I didn't have anything in my stack. It will give me garbage value. and then I know that, oh, the return address has been already pushed in the stack by MUP. So there is nothing called garbage value in there now. When you're calling a subroutine, there is the return address that is being stored. So whenever I do pop h, means I'm getting the return address. Okay, so the return address will get stored at h, and you will lose your return address. Now when this program executes, the return will get to, you don't know where the return address will get stored by then. It will go to any random memory location, and it will not get your desired output. So this program teaches you that never ever done a pop operation first in subroutine. Then how can I use stacks for sending parameters? Okay, so you can use HLL Pair here also. You can give any data, right? Suppose 2020. Okay, I'm just kidding, okay? Forget 2020. So in a program, it's thought that I have initialized LXI h, 2020, and I just need this data. So you will write call sub. I just want this data to get stored at my stack. So what will I do? Pop h. But my return address will get stored first. RAH RAL 2020. Okay. So data of HL register has been pushed. I'm really sorry. So now I want that data get out also. Probably thought that I can get that data in BC register. So we will just do pop B and C will get the data 2020, and then I want my return address, which is stored at stack. But how can I get the return address at something that it can get me back to my desired location, to my return address? How to get my return address back? You can just do this instruction, pop h. So now h and l will be RAL and RAH, then PCHL. So PC will get this return address, and it will get back you to your desired location. In this addressing mode, what is happening that in this method, this is not an addressing mode. In this method, whenever I'm sending some parameters, I just want to store my parameter at a location in stack. What is the problem that occurs here is the return address. If I want to store some data or get out some data, if I operate any push or pop operation, I might lose my return address. So to recover my return address, PCHL instruction is the best, right? You can get back your return address. You just have to do this pop h operation, then you will get back your return address at HL, and then after doing PCHL, we will get back to your return address. But then also, what happened? The problem in this instruction is, see, using stack, we have unlimited access to memory. I can store any number of parameters that I want to store. But then also, here in this case also, the HL pair gets blocked, right? Because I have to get back my return address. So this is why HL pair is get blocked, and to recover my return address, I need to use that. And if I'm operating any program, I want all my registers to be free. But so this is the drawback of this method of passing parameters using stack. So this was the 4 methods that are used to pass parameters. For the first time, all these 4 methods seems to be same. What are the 4 methods? First, register. I can use any register to send any data. Then my registers will get blocked. Then I can use any memory address. But then a particular memory address will gets blocked, and I don't know, because I can randomly choose any, and if any operation is already being performed in that memory location, then my operation doesn't make any sense. Then I can use memory pointer. In memory pointer, we are just holding the HL block, and by decrementing or incrementing, we can use any address that we want to store data. And the last one was stack. But in stack also, to recover the return address, I need my HL pair. So this was the 4 methods that are used to pass parameters into subroutines. So basically it's just a value that will be sent by the main program to a subroutine. So this was it for today's video. If you have any confusion, please ask me in the comment section, and I hope you like the video. Keep watching. Thank you.